Hello, hello. How are you guys doing? Today is Friday, and yeah, I'll be doing a bit of streaming before I head on out into the world. Um, I'm gonna arrange myself with an alarm so I'll remember to end the stream. Yeah. So, as you might expect from the title, um, I want to do a system here. And let's do a shape here and arrange the text properly. Okay, so I want a uh, building system. Can I add an outline to this? Uh, there we go, should be. Oh well. Well, it's maybe related to layering then. Let's see, maybe this one. No color. Well, we have a border. Why? Okay, being sent backwards. Bring to front. Please. Okay, we just need a thicker outline or what? Uh, uh, no, that's thick, I guess. Okay. Could also just make it left here. It doesn't really matter much, but okay. Let's increase the text size as well. I can't. Maybe 400. Okay. So we want a building system. So what I want to be able to do is simply stamp down buildings, uh, at least for now. So in our world, we have a grid, and on that grid, I would like to be able to actually place some buildings by clicking a building in a panel and stamping it down. So in order to do that, we need a panel, building panel. We need a hologram slash stampable building thingy. We need some math to translate from screen space to grid space. Let's just zoom in instead. Okay. Do we need something else? Well, we will add it. At least for now, this is what we need. Inside this, we probably need some systems to handle the actual building logic. But first of all, we want to be able to kind of like make a tool or UI thingy that allows us to build some stuff. Okay. Let's start with the math. So basically, we kind of like have a way to translate into what do you call it? We have a way to translate from the screen position of the mouse into what do you call it? X and Y coordinates. So I think that we want something like for each frame update save the X and Y in both now in screen pause of the mouse and translate it into world space coordinates. Each frame, save the translate mouse position into world space coordinates X, Y, Z. Save mouse click state. Save hovers windows. Let's see, maybe do something called flex. Frame flex. So basically, let's do game state, something. Mouse. Well, let's do flex and let's do an overview here. We have 0, or rather, well, is it called 0? First bit equals mouse 1 clicked, 2 mouse 2 clicked, potentially 3 mouse 3 clicked. Let's do 4 hovers window. Okay. So we will simply store a uint 64t flags. Jesus, my neighbors keep on drilling in the walls and it makes no sense. It seems like they never get done drilling. Just keeps on drilling and drilling and drilling. It kind of makes me insane. Let's do uint 64t. Let's just do something like one. Nah. Oh, it's. What's it? It's it whining about? Okay. So for game state flags 1. Does it know how to translate a bool naturally? Well, I don't know. Let's just see. Wait, whatever. It still thinks that this might be a fast way to cast bool to int 64 C++. Oh well, seems like we have a guarantee here. Yeah. Let's try printing this out. Flags. We did get a 16 right. Okay, 16. If unlike 0, let's only catch it when it's not 0. Okay, doesn't work with ImGUI then. Ah, okay, something about the. Well, I mean, this should basically be. Oh, I need to add it, of course. There we go. Yeah. Yeah, there we go. So we can store our flags on the game state. Okay. And then we can do something like we could convert it into if enum just for readability. Yeah, I think we should do that. Okay, let's do that. So our game state here. Should we add it inside this? Well, nah. Enum class game state flags. Enum class UN64. Okay, I can specify the there we go. None mouse one click, mouse two click, mouse three click, hovering window. Okay, we have the game state flags. And then we can do game state flags. Huh? Why doesn't that work? I mean, do I still have to cast it? I guess. Can I then? No. Okay. Apparently I can't do it that way. uint is this better? Unsigned. No. Okay. So I need to look into some stuff here. Okay. Okay, scoped, unscoped. enums, blah blah blah. Okay. Okay. So this is more readable, right? Even though it's basically some of the same stuff going on. And then we do if game state flags and mouse one click. Should still work, right? Nope, it doesn't. Okay, it keeps on clicking here. Okay, let me see. Huh. Huh? This is not right. Yeah, this is not right. Check if bit is set integer. I mean, flags. Weird stuff, weird stuff. Two? Oh, maybe. Maybe. Okay, so it's 0 indexed. Or what? No, but it should still be fine. I mean, and flag. Flag is 1. $16. Let's see, calculator. 16. Yeah. But it's not the 4th bit. Okay, I need to change the offsets then. Let's try this then. Okay, yeah, of course. Of course, now I know why. It's because I'm not bit shifting this, so... But the AND should check whether... I mean, let's try redoing this. None equals 0. 1, 2... let's just make the compiler interpret this by itself. So for some reason we end up... Maybe we don't want to bit shift it. So let's see, if we do 1 and bit shift it 1, yeah, we end up with a 2. Okay, 0 plus 1 bit shifted 1 is 2. Okay. 0 plus 1 bit shifted 0. And we set the first bit. Okay. Okay. Flag 0. Do we need to... If I do something like 1, it will work bit shifted like this. This would work, I think. Yeah, as you can see, it works fine. But I guess, well, we would need to check whether it's true or false, I guess, the way we kind of like register the flag. We could also just do an if statement, and then if this is true, we add set the flag. If it's not, well, but since we're fetching this already and we have a value, I guess, and maybe the compiler will know what value to compare this to. Yeah, we could look up the assembly, but yeah, I'm not gonna bother right now. Okay, so can I even write it like this? Yeah, I guess. Okay, so we can start replacing this, and if we do the same thing for, yeah, we basically don't need this. We could do a flag here like false on the hovering window flag here. Or what? No, we can't. uh, yeah, this ends up being 0, right? Okay. Yeah, this is not supposed to be able to happen, so let's see. Equals 0, right? Well, no. Huh. Okay. We can also just invert it, right? No. Okay. No. Yeah, we do. And okay, so if we're, I mean, this is not supposed to be possible because we're hovering a window, right? Let's see. Yeah, we shouldn't be able to do that. It kind of like ignores the flag. Maybe we do like this. Huh? Now I can click here, but I can't click when I'm over the window. Okay, so that's it. Yeah. Yeah, we could do true. So if we set our flags each frame, set frame flags. Yeah, right now we don't want to do this. We don't need it. Okay, and then we want to get the mouse position here. Game state. Let's see. Let's see. Mouse. Screen space. Float mouse X. Float mouse Y. Mouse X. Mouse position X. Mouse Y. Mouse position Y. Okay. Okay. And we grab the world space X and Y and calculate the C. Okay. Let's do a raycast here. Each frame. For now, we will set the stuff here temporarily. DirectX XM vector ray direction. DirectX. This is just temporary. Ray origin. And this should still work. Yeah, we're fine. And then we need to find a point on the plane with the find point C coordinate on the plane where y equals 0 and the normal is a normal vector in the direction of y. So we want to find an intersection between this ray and the plane that we defined here, where yeah, it's basically the at 0, 0, 0. So let's see. Let me see. What's the math behind a ray plane intersection? Can't remember. I can't remember. Whoops. Bum 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 ba ba da ba da ba da dum. Primitive test, additional test, blah blah blah. Let's see. So okay. So Maybe, I don't know, no, DirectX Math doesn't have a fast way to do it, I think. Okay, I think I have a way to do it then. Okay, let's open the race. Bool ray intersect plane xm vector ray origin. Simply copy this and then a and then a xm vector reference center. Let's do plane center and then xm vector normal plane normal. Okay. Let's see, does these two algorithms no. Well, maybe this is for the simple true or false evaluation. Okay. Okay. Let's do a DirectX. Nah. Yeah, maybe just a bool. Ray intersect plane point. But also do a DirectX XM vector out point. Okay. And maybe we actually need the D component as well. Sounds dirty. Point. And also float plane D. Plane distance is better. I guess we could. Nah. Float plane distance. Let's do a const float here. Yeah, let's redo this. So let's promise not to change any of this. Let's add the same up here, just for good measure. Yeah, we pass out the distance, that is fine. Okay. This is fine, this is fine. Let's do... Yeah, since we're not gonna change the... Okay. Hello, buddy. How are you doing? I'm happy to hear. Are you off for the weekend or? Okay. Definitely something relates here to the float denominator, where we do the yeah. Let's do a XM. Do I using my yeah? Okay, so I can just XM vector dot vector 3 dot between the plane normal and the ray origin divided by maybe I should check whether this is 0. Maybe I should check whether it's 0 because I could potentially end up dividing by 0. I'm pretty sure I need to. We could do plus float epsilon here. And then do a dot product of our direction, ray direction, and our plane normal plus a float epsilon here. And let's see, plus distance, plane distance, I think. And let's just call this T. All of this is supposed to be negative. T is larger than 0. Then our out point is equal to xm vector add array origin xm vector scale here, array direction, and our t value here. Return true. I think this is the way. Let me just check. Yeah, I think this will be okay. So, whoops. XM vector. Intersection. Oh, there we go. Okay, and we do our core collisions. Ray intersects plane point. Let's grab the origin. Let's grab the ray direction. Let's set our vector here to 0, 0, 0, 0. And we want the normal here to be 0, 1, 0, 0. And we want the distance from the origin to piece 0. And then we want our intersection here. And this should give us our, what do you call it? Our intersection point on ground plane X intersection, not interface, intersection. What on earth is happening here? And do I actually have a register? No, I don't. Ah, okay. Not gonna spend time doing that. Y. C. Zero, zero, zero. Huh. So if we seem to have a, we don't. Well, this algorithm is not working correctly then. Okay, let's step into this. Okay, so we have a 0, 0, 0 for the plane center, distance as 0, the normal of the plane, the ray direction. Okay, let's see, what does t end up being? It's negative. -5. Let me just try out not negating this. I'm not sure it's right. Let's see. Yeah, this is not correct, I think. I mean, if I move the mouse up here, yeah, we end up, this should be somewhat close to the origin, right? This should be the origin. We're pretty close here. Pretty close. But it doesn't really work correctly because let me just move this off screen. Because the C value here keeps on being too high. Yeah, the algorithm is not working as intended. Let me just check this then. Hmm. And the I mean, it seems like the X is not correct. I should be pointing at the origin right now, and we should be intersecting more or less, or in general, like, uh, hello, buddy. How are you doing? Okay. Okay, I'm maybe starting to get there. Okay. Yeah. So if the dot product between the normal and the direction of the vector, the ray lies on the plane. If the dot product between the point on okay, starting point. Let's see. Okay, does this need to be... This is the direction. Yeah, maybe I need to... Maybe I need to do something like... XM... Now let's do... the plane center minus the ray origin. Let's do that instead and see if that works. Seems like the X is getting better and also the C component. Wow, that seems to be precisely what we want. Yeah, we're pointing at almost the origin here. Okay, let me just move this off screen and see if I can point at the origin right here. Yeah, I can almost exactly hit the origin on all three axes. And the y will always be 0, which is great because the plane is always on 0. So we basically fetch the x and y coordinates in world space now with this algorithm. That's perfect. Okay. Okay. I would like to test it if the camera ever got below the plane, actually. Let me just move this off screen. So what happens if I end up under the plane? Yeah, it still works. It still works, it still works, it still works. Okay. Awesome. Awesome. And as you saw, whenever we're parallel, we won't be pinging up any intersections. I don't know if you noticed, but I did. Okay. So our game state will be able to save our oh, we don't actually have a parameter for that. Float world space x, no, grid space x Load, grid, space, Y. Let's do a pause here just to make it more logical what we're actually doing here. Mouse position X. No, it's not grid space. It's world space. Screen. Screen. Okay. Y. World space position X. Intersection. Okay. And our game state now knows where our mouse is hovering in terms of this grid here. It knows it all the time. All the time. So we're done here. So yeah, I got about an hour before I gotta go. Okay. So we could just for fun maybe what are our models here? Well, we could for fun just do some crazy stuff, I guess. Test box, I don't know. Can I? Yeah. Okay, so it's basically just a cube. Okay, if we do load our spaceman. Let's see. Let's do something like models up here. And let's do like this, and then let's just do the same thing as for the spaceman here. Test box. And let's load the test box. And this should compile fine. Okay, so we will have a very, very silly but Let's do test area, submit. So let's do a game state mesh buffer in place back with a XM float 3 here, which is our position, which we will grab from our game state, where we simply ask for the mouse position here, the X coordinate, no, not screen, world space position. I mean, this name is also bad. World space mouse position. Yeah, this is better. And let's just do maybe 0, maybe 2 up here. Yeah, I don't know. I say up here because it's gonna be floating in the air, I think. Okay. Aren't we? Huh? Oh. There we go. One parameter. Okay, okay, okay. And we just do a standard model scale. 1, 1, 1. And our orientation is just going to be a XM float 4 0 0 0 1, and then maybe is it number 2? Yeah, I think so. And just a material 0, a texture 0, and that should be it, right? I hope so. Okay. So I'm in trouble here. Mesh buffer, renderable mesh. Oh, it's an XM vector. Therefore, we just do like this. Oh, I need to do this also. Okay, as you can see here, we have a cube that follows our thingy around. And we can't get rid of it. It's like stuck to our mouse no matter what we do. Okay. So this means that our thingy here could be snapped to our grid. Look at that beautiful shadow mapping. We can even put our guy here in shade. Okay. Okay. Maybe we want something like a scope for this, and then float x, float y, c rather, and let's do some kind of like wrapping calculation. So, uh, uh, and if we change this, we end up with some weird everything just gets smaller, but so everything is 1 here. And if we do then our player is just smaller. Yeah, I guess we shouldn't scale our models in general. So I can't remember the tile model itself. Chest tile. Let's see. And if I look up the model itself, let's see the tile itself. So we have the vertices here. Okay. So it's basically 2 times 2, right? Yeah, it's basically 2 times 2, which could be which could be an argument of just removing this, scaling him down, and then do we add an AABB or what? Okay, we'll manipulate the AABB as well. Basically, that's what we're manipulating right now. And when we submit our tiles for rendering, I think I have hard-coded a multiplication here. Yeah, I mean, the tile width itself should be the value that we actually use for controlling this, so I suspect this will be better, right? And if I click somewhere, okay. So we end up in a situation where Man, this stupid test object is really annoying. Let me just disable it. No one wants a box floating around in space. Okay, maybe it works fine. Yeah, I think that's better, even though let's do a and let's just have this. And inside our application, when we create the position here. Okay, the second one is the offset, right? Let's try this. Okay, so we have our thingy here. We have our thingy here. And okay. Let's do this. Okay, this ends up making a lot more sense. I think actually this is supposed to be a half for us to be inside the center of a tile. Okay, okay, so each tile is now 1 by 1, which makes way more sense, and also is what we specify up here. And we're not doing random multiplications or whatever over and over. So okay, and our collision still works as it should. Okay, let's enable our funny thing again then. Yeah, so the building system is something that kind of like needs to round this x coordinate. Let's see. Fast rounding. Float. All right. Let's try doing this just for funsies. Let's see what happens. And we have immediately snapping to a grid. Isn't that beautiful? Even the shadow seems to be scaled into the grid, but that's just because of the mighty world lights that have a very specific direction vector. We can always just try changing this a bit, and immediately we see that our shadow kind of like gets not aligned to the grid. Anyway, okay. So basically, what happens if we set this to 0? Will it just float around on the... No, it will have... I think this is 2 by 2, but yeah, we would definitely just do some manipulation with the model itself and store the offset into the center on the y-axis. Okay. Basically, this is a lot of our building system. So far we have created a snapping algorithm in terms of our grid. We have created a way to, for each frame, store our X and Y position in world space. Basically, we could alter the selection, what do you call it? The selection, uh, the selection X and Y, and use that to kind of like decide whether we clicked on a tile. But I guess, yeah, we could also store the Y, well, to determine which object near a specific tile that we actually clicked on, if there are several tiles, or rather things on the tile. Anyway, this will basically allow us to always have a sense of, even if we hover over a tile, for instance, um, if I'm hovering over this tile here, maybe we have some area that shows, well, this tile contains blah blah blah, or whatever, and it will always be accessible because it simply maps onto the grid. And you can see, okay, we need to move it a fair bit on the Y before it decides that the C value will change. Well, maybe it's just the angle. Yeah, it's probably just the angle. Okay. let's do. Yeah, I want to debug this. Uh, so let's try debugging just what tile we're over. Hovering tile at X, C. There we go. And let's see, hovering tile. This should be, well, yeah, definitely not how we would want it because we want, maybe we don't need to. Seven times seven. That seems more reasonable, right? No? This is supposed to be 0 then. Maybe even then just +1. I don't know. Or maybe just afterwards, but 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Do I actually have 9? I just realized I have 9. The grid is 9 times 9. Why didn't anyone tell me when I did the chess game that I made a weird chessboard? Anyway. Anyway. Why do we end up with... Are we... Let me see. I mean, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. -1 then? No. Huh. Did we do... This should be fine. Huh? Why do we crash if we do that? Is this not dynamic? Maybe I just didn't allocate the correct ones. Anyway. Okay. Now that's we. And I also. Okay. Huh. -1. No. Okay. Yeah, we're messing up totally. We have some weird memory stuff going on here. And if I disable this, does it just... Yeah, it's because we don't emplace back, but instead simply assign. Let's just do something else then. Float x. C float y equals r. Maybe we just want something like tiles. Push back. X, Y, and then material. So C, R, 0. Mesh should be 0, right? Nah, tile UID. Huh? Huh? Let me see. Oh, wait a minute. Wait, blah, blah, blah. I don't know what I'm doing here. It's of course due to this. I think we're trying to access something we can't access. Okay, we're still having trouble, but let's see. Okay, where do we crash then? We should be fine right here. This is also fine. Okay. Okay. Be a bit more specific, please. So we're definitely not crashing there. We're crashing somewhere in here, I think. Let's see, blah, blah, blah. This is all fine. Simulate is fine. This is fine. This is fine. Oh, okay. We try to access a AVB that's not created because yeah, I guess we could do this. Let's see, C. And then R here. Okay, this should allow us to dynamically allocate our stuff here. And yeah, get out of harm's way. Okay. Yeah, I think this is the index, which is fine. Yeah, I think that's fine. So now our stuff here is 8 times 8, and our kind of like mouse in screen coordinates to grid coordinates is being mapped properly. We can see that whenever we kind of like transition over the border of a tile, it uh, recognizes that we are actually on a different tile. Okay, this is not needed anymore, and we have a more generalized method, which is also great whenever we decide to change the tile set. Not original, we don't need that. let's just do the, oh, not reserve. There we go. Okay, our player creation, our different stuff here, and we have our math here. And if we re-enable this temporarily, it would of course set the center of the object to whatever we're pointing at. I think, no, it doesn't. Okay. It basically sets the starting point or what? It seems like it. Okay. Anyway, we got some progress made. We have done this. Next episode, I'll probably do the actual building panel. It's just some simple ImGUI stuff, and then maybe do a sort of, yeah, I don't know, some kind of way to make a hologram object for stamping down. Yeah. Yeah. I'll probably do that. Figure out some way to do that nice and elegantly, so that whenever we, for instance, click a, I'm gonna disable that one. Whenever we click some panel down here maybe, and we want to place our building, we will be able to see a sort of hologram, kind of like floating around here. Maybe we just want a special texture for it. Yeah, maybe we want that as a start. I'm unsure whether it should actually cast a shadow. And we're starting to get into a kind of like territory where we should probably do some kind of like grouping of objects. So our renderer should support uh, different render groups so that we could render something without a shadow, maybe with a special effect applied to it or whatever. Excuse me. Or with a blend mode. So yeah, maybe that's something that we need to do. Building system. Let's see. if we do like this and then do something like a shape, renderer, whoops, renderer, and let's do red stickies here, grouped rendering, uh, um, um, flags, i.e. cast shadow, visible, special, and depending on whatever flags these render groups have, it will get submitted to different parts of the pipeline. I mean, so this would need some kind of like, yeah, we would have to change the things here. Maybe we need some kind of like render command thing. Render command buffer. Yeah, I don't know. I mean, this is basically going to be done for every polygon that we want to draw. But I mean, we need a way to bind different render passes or special cases to our backend here. But yeah. Let me worry about that later. In general, I would like something like, well, our front end should be able to do something like submit and draw. Maybe even record draw command ish, like with the mesh pipeline. Yeah, maybe we want to do it that way. So I shadow mapping, uh, solid meshes, transparent meshes, texture, material, this is something like vertex, index, index startup. So this is probably something that we would like. And yeah, we need some efficient logic here. And yeah, this gets sent to the backend. Um, yeah, which kind of like registers these draw calls. Maybe sorted by group. Yeah, maybe. Anyway, I gotta go. Thanks for tuning in to everyone who joined the stream. I hope you found it entertaining or a bit helpful. Or yeah, feel free to consider supporting the channel or yeah, um, joining the stream in the future. Also, feel free to join the Discord server. Yeah, hopefully I'll be seeing you guys around for some more game engine work. Okay, take care.